Hello and welcome to Engineer Simple. So I'll continue talking about kind of what is a power system bus. When you had a bus, what does it mean? So I kind of draw one line you typically see when you are dealing with power flow or load flow. Usually it's one line, and also the bus is just like a vertical or horizontal. Sometimes if a dot is represented, then I kind of gave at least three common options for representing a bus: straight bus, ring bus, and break and half. So I went ahead and did a straight bus representation, and also I talked about some of the disadvantages of a straight bus, and it has advantages too. Sometimes if you don't have space, budget is tight, a straight bus is a way to go. Now let's do a ring bus option. So we have for a ring bus, since I have, so I'm only doing bus 3. So assume this is a substation. So bus 3, I have 4 lines connected to it. That means I'm going to draw 4 breakers. And like we did for straight bus, we're going to have disconnect switches around the circuit breakers for maintenance purposes. So each breaker will have it will have 2 disconnect switches. So the square is a breaker. So power circuit breaker. And this here is a disconnect switch. So this could be a transmission, basically substation 130 kV and above, 345, 230, 500 kV. So the difference between a circuit breaker and a disconnect switch, the circuit breaker can interrupt load. That means while power is flowing, the breaker can open. It's designed for that. Also, if there is a fault, it can interrupt the fault current based on its capability, what it's designed for, without damaging the breaker. Disconnect switches, typically they cannot interrupt load or fault currents. Sorry, I forgot one switch here. So typically disconnect switches are for visual indication. That way, visually you can see the circuit is open because you will see the blade is, kind of not connected to the bus. And also, if you want to maintain this breaker, for instance, without kind of taking lots of outages, you just open this switch, and then you can safely do work on this breaker. So anyway, so basically the way the ring bus works, between any 2 breakers, you connect a line. So I have 4 lines. So here's a line. So basically this is a line. So it goes to another substation. I'm just gonna represent the substation with a bus. So this is a line. So there is some distance here, probably 20 miles, 30 miles, 50 miles, it depends. So this is another line. So between this breaker and this breaker, I'm gonna draw another line. And then another line. So now let's see some of the advantages of the ring bus. So if this line faults, for instance, it's faulted to ground, like a tree falls on it and it completes a path to ground. So it will go back. So this breaker here and this breaker, they have to open to isolate this fault, and also the breaker that's on the other side, it has to open. Then there is no complete path for the fault current to flow. So then if a breaker fails, say like this line to ground fault, these two breakers, they have to open, trip, to isolate this fault. Let's assume this one here, somehow it did not work. Somehow it was not working properly. Then it's going to transfer the trip to the next breaker, which means this one here. Then you are only taking out another circuit. So this line here will be already out of service because it's faulted. But then this line here will be de-energized. So it will be taken out of service. So out of the 4, with the ring bus, only 2 lines could be out of service, and the other 2 would stay in service. We saw with a straight bus, if this breaker here fails to open for this line to ground fault, the entire station will be out of service. So that's one advantage of the ring bus over a straight bus. So that was it for the ring bus. Thank you and have a great day.